Yo, what's up guys, in the last video I finished coding all of the pieces for chess in Minecraft. We're going to take a little step back from coding the actual chess pieces and talk about how the computer is going to put all of this together. Today we're going to talk about 1. How the computer is actually going to display the chessboard, 2. The IDs of each of the pieces, and 3. The notation. How are you actually going to tell the computer where to move? I coded the paths of the chess pieces assuming a standard coordinate grid, and the normal chessboard actually reflects this perfectly, where it uses letters as the x values and numbers as the y values. So I took this coordinate grid and I gave each square on the chessboard a specific number. So the very bottom left corner would be 0, then 1, 2, 3, 4, 5, 6, 7, and then the next row 8, 9, 10, etc., all the way up to 63 in the top right corner. And this would work very well. The computer is perfectly aligned with a standard chessboard. And now I can take any coordinate on the chessboard, like b6, and actually convert that to a number for my computer to understand. But the only issue is my screen. Cell number 0 on my screen isn't actually the bottom left corner. It is the top left corner. So how can I fix this? Now I have to actually do some calculations to correctly map the internal chessboard to the screen. Before we tackle this problem, we have to fully understand how the computer gets these values. Because there are 64 squares on an 8x8 screen, I have to represent each value by at least a 6-bit number. How it turns out with these 6-bit numbers, the bottom 3 bits represent the x value, and the top 3 bits represent the y value. Both the screen and the chessboard actually increase the value going from left to right, so we don't even have to worry about the x values. But it is the y values that cause the most trouble, because the chessboard moves up the y values, moves from bottom to top with the y values, while the screen moves from top to bottom. And because the screen and the chessboard are exactly opposites with the y values, I can actually just not or inverse the y values of the chessboard to get the y value of the screen. We see that 0 knotted goes to 7, 1 knotted goes to 6, 2 knotted goes to 5, 3 to 4, and then 4 to 3, and then reverses the other way. But I would have to isolate the top 3 bits, knot them, and then apply them back to the number in some way, which I think is too many operations. So how can I actually simplify this? I can actually make use of an operation called the XOR, and it's very interesting, where 0, 0 is 0, 1, 0 is 1, 0, 1 is 1, just like a normal OR gate, but 1, 1 is 0. Now notice whenever the b value is 0, the a value stays the same, but whenever the b value is 1, the a value knots. It actually inverses. And so I can use this fact to knot specific bits in a number while leaving the other bits the same. So, for example, if I were to take the value 2, 1, and I were to XOR it with 1, 1, 1, 0, 0, 0, it would actually flip the top 3, turning the 2 to a 5, and leave the bottom 3, the 1, the same. So now for each square value, I can simply apply this XOR operation in order to correctly map it to the screen. Now let's talk about how I'm going to assign a value to each of the pieces. There are 6 different pieces in chess. There's the pawn, the king, the queen, the bishop, the knight, and the rook. So this means that I need at least 3 bits to define to identify each piece. But I also need to have some sort of information describing what color they are, either white or black. Now normally to display 2 different states you only need 1 bit of binary, but because of how I coded it in some places, I actually need a 3rd state which says no piece, that there's a blank space. So now because I need 3 states, that requires at least 2 bits of information. So now 2 bits plus 3 bits is equal to 5 bits. So now finally I can ID each chess piece with only 5 bits, 3 bits for the type and 2 bits for the color / if it's there or not. And so the final thing I want to talk about is notation. How am I actually going to enter these different moves into the computer? Now for every type of move, I'm only going to have 4 separate characters. Now for any standard normal move, like moving a pawn forward by 1, or moving a bishop or a rook or a queen, I need to use 2 of the characters, the first 2 characters, for the starting position of the piece, and the second set of characters, the last two characters, for the final position, where I actually want it to move to. I also want to add castling on both sides. Now, for those who don't know, castling is a special move in chess where if you haven't moved your king or one of your rooks, you can almost swap places with them like this. Now, standard notation for a kingside castle is O-O, and standard notation for a queenside castle is O-O-O. Now, because I don't have 5 spaces, I'm going to do 2 O's for a kingside castle and 3 O's for a queenside castle. Now, another special move is something called the en passant, and if a pawn does a double move, goes 2 squares forward, and there is a pawn right next to it of the opposite color, it can actually move diagonally and take that pawn. Now, it's a very rare move, but it would be just rude to not put it in the game. So the first two characters are going to be the current position of your pawn, and then you put P for passant, en passant, and then you put the X value, the letter that you want it to jump to. The final move I want to cover is something called promotion. When you get your pawn to the other side of the board, it can actually change into any piece you want, except for another king. But I have a few different ideas on how to do it, so I will officially decide next video. So today I talked about how I can map the chess coordinates correctly to the screen, how I can ID each piece, and how to notate some of the weird moves. Next video I'll show you guys first of all how I'm going to notate the promotion, and then I'm going to actually code some of those weird moves like the castling, the en passant, and the promotion. So stay tuned for that, and peace.